Some of the terms that you will hear when we talk about Earth's motions, the first of which is Barycentre. And what Barycentre is, it's the balancing point between two celestial objects. The way that you can think of this is if you were sitting on a teeter-totter. If you are on one end of the teeter-totter and two people are on the other end of the teeter-totter, in order to balance out that teeter-totter so it doesn't sink down to the side of the two people, you would have to move that pivotal point from the middle in one direction or the other. In this case, you would have to move it to the side of the two people because that is where most of the weight is concentrated. When we talk about the Earth and the Moon, for example, the barycenter, or the balancing point between the Earth and the Moon, lies about 1,700 kilometers below Earth's surface. The same thing holds true for the Sun and all of the planets. The balancing point, or the barycenter, of the Sun and whatever planet you are dealing with is going to lie within the middle of the Sun, almost to the point of the center of the Sun, just in order to balance out the weight between the two objects. Because of this, we see that the Sun is evolving around its barycenter because of all of the planets pulling on the Sun in multiple directions. In the reading, you'll see a animation that shows you how the Sun is moving around its barycenter to stay balanced with the planet that is orbiting around it. When we talk about the motions of Earth, the main two we all know are rotation and revolution. We know that Earth is rotating or spinning on its axis, and it takes 24 hours to complete one full rotation. This is the reason that we experience day and night. When we are facing away from the Sun, it is nighttime, and then when we rotate around 12 hours later, we experience daytime because we are pointing directly at the Sun. Revolution is the orbiting around the Sun. It takes 365.25 days. That extra 0.25 days is the reason that we have a leap year every 4 years, in order to account for the one full day that it would add on. If we didn't account for this extra day every 4 years, eventually, over a long period of time, our seasons would be slightly off, going, every 4 years adding one extra day. Eventually you're going to be a month off, then 2 months, 3 months, and winter will then become summer, summer will then become winter. So because we don't want that to happen, we account for the extra 2.5 days a year it takes for the Earth to fully make one revolution around the Sun and keep our seasons the way they are. When we take a look at the Earth's position around the Sun, we talk about perihelion and aphelion. Perihelion is in January, and that's when Earth is closest to the Sun. You might be thinking, well, if we're closest to the Sun in January, why are we not experiencing summer and we experience winter? And that's because during that time we are actually pointing away from the Sun, and we'll talk about that a little bit more here in a couple slides when we talk about seasons. Aphelion is then just the opposite. It's in July. It's when Earth is at its farthest point from the Sun, but the reason that we are experiencing summer is because the northern hemisphere is tilted towards the Sun at that point. While Earth is orbiting the Sun, it is not in a full circle. It's in an elliptical. It's in a more oval shaped. So we know that as we're revolving around the Sun, when we get closer to the Sun, we are moving at a more rapid pace. When we get further from the Sun, we are moving at a slower pace, and it takes us, again, 365.25 days to go around the Sun. Precession is the slight movement of Earth's axis. Earth's axis is tilted 23.5 degrees. As we are then rotating, the axis is not able to stay in one set point. It has a very slight movement in a circle. If you look at the diagram in the lower right hand corner, you'll see that it is moving in that circle very slowly, and it makes a complete cycle once every 26,000 years. Currently we are pointing at Polaris, that is the North Star that we know, and in a little under 12,000 years now we are going to point at Vega because of the change in our precessional axis, and we will then consider Vega as our North Star. Nutation is the kind of wobble of that precessional axis wobble. The nutation changes about a half degree. If you look at the diagram, you can see as the precession is going around in a circle, you will see that it is also going to move back and forth. And the reason for this is because of the gravitational pull of the moon. This occurs at a much faster cycle. About every 18 years we experience one full cycle of the wobbling of our precessional axis. And the last thing that I want to come back to is seasons. So if you look here in this diagram, at the left you'll see winter, and you see that our axis is pointed away from the sun, so the direct sunlight is hitting the southern hemisphere of Earth. That is why, even though we are at our closest point to the sun, the direct sunlight is on the southern hemisphere, so we are only receiving indirect sunlight in the northern hemisphere, and we are experiencing our winter. Then the complete opposite holds true for summer. Even though we are furthest away, the northern hemisphere is tilted towards the sun, so we are experiencing the most direct sunlight in the northern hemisphere in our warmest months of the year, or our summer. And then during fall and spring, we are neither pointed towards or away from the sun. The direct sunlight is hitting the equator during those months, which is why it is more of a moderate temperature.